Probably you know that every year there is a new release of ROS 2, and this year has not been different. So we have the release of ROS 2 Jazzy, and with this conference, in this conference, what we want is to provide you with the first insights about the improvements that you can experience if you change to ROS 2 Jazzy. And for that, we have Alberto, who is the head of education of the construct, and he's going to do a review of ROS to Jazzy and tell us the most important or interesting things that you can find if you decide to install ROS to Jazzy or you are considering about migrating from a previous version of ROS 2. Alberto, are you there?
Hello, I am here.
Yeah.
Can you
Okay.
hear me?
Yes, we can.
All right. So, yeah, hello, everybody. I want to start by saying some quick words. So, this is the last workshop of the conference. I know there's been many hours of amazing talks, workshops, learning sessions. This is the last one. So, let's finish with energy, okay? Let's finish with good energy this conference. Then I'm going to be doing a light presentation. We are going to have a project where we are going to be able to do some cool demonstrations. And then also stay tuned because at the end, I am going to be connecting to the real limo robot, to the real limo lab that we have here in our offices. And I'm going to be testing some of your projects one by one, and depending on if it works correctly or not, selected randomly, but testing your code in the real robot, and then we will see who wins the limo challenge and who wins the limo robot. All right. So yeah, without further ado, let's get started. Let me start sharing here my screen. There we go. All right, so I hope you all can see my screen here. And yeah, so today we are going to be having a quick overview of some of the new features that have been added with the latest ROS 2 release, which is named ROS 2 Jazzy Jalisco. And there are many features, many things that have changed with respect to the previous version, which was Iron. Here I have just selected a few that I think are interesting for can be interesting for developers. And yeah, we are going to be reviewing them. So my name is Alberto. I am the head of education at the Construct. Probably some of you already know me also from the open classes or from the masterclass. And yeah, so let's already jump into the action. So Jazzy Jalisco, as I was saying, is the latest ROS2 release after Iron and Winnie. It has been released barely a month and something ago, May 23rd. And one important thing about Jazzy is that it is an LTS release, which means long-term support. Yeah. So this ROS2 release is going to be supported until May 2029. Yeah, so it's 5 years. Then why I'm saying this? Because maybe if you have some old code, this is a good moment to migrate it to ROS 2. All right, or even if you have ROS 2 code but in an old version, I don't know, maybe Foxy or something like that, this is a good moment, this is a good release because it's going to have a long-term support, right? Then here I have also added a link to the full official document for the release, in case that you want to check all the different things that have been added, modifications, and so on. The supported platforms are the same as for the previous versions. So the tier 1 platforms are Ubuntu 24, well, Ubuntu 24, Noble, and Windows 10. There are some tier 2 and tier 3 platforms also, like Red 9, macOS, which are supported experimental, let's say. Yeah. Then the first thing I want to introduce and the first thing that I want to talk about in this workshop is about the Gazebo Sim integration. Okay, so far it has been a bit messy to integrate ROS2 with Gazebo. In the latest releases, it was a little better, but especially in the old ones like Foxy, it was a complete mess. So now, starting from Jazzy, starting from this release, there is going to be a Gazebo Sim release associated to every ROS2 release. For example, in the case of ROS2 Jazzy, the associated Gazebo release is harmonic. All right. This is a concept which is similar to what we had in ROS1, where every release of ROS1 was associated to a Gazebo Classic release. All right. Then, in order to achieve this, what has been released are the Gazebo vendor packages. Here you can see a list of all the packages. And basically, these packages, what do is to provide by default. Yeah, so when you install ROS, when you install ROS to Jazzy in your system, you are going to already have this by default. Yeah, and these vendor packages, what do is to provide all the necessary Gazebo libraries for ROS. Yeah, then let's start by opening a shell and have a look at these packages. We are going to be able to find them here already installed. So let's open a new shell. At this point, you should already know how to do this, even though I have also explained it here. Yeah, also, for me, it did not open automatically for some reason, but whenever you open the project, probably for you, this has automatically opened and runs. And this is going to install some packages. There we go. All right. Then let's try to execute this command, very simple ROS2 package list. And we are going to filter to see what packages we have installed in the system with the GZ characters. And then we are going to be able here to see that we have all these vendor packages installed. Yeah, all this has been introduced in Jazzy. And the goal of these vendor packages is mainly to make this integration between Gazebo Sim and ROS2 much more smooth. All right. So, for instance, we can run. Okay, let me do stop a moment here because I have noticed, and this has happened to me several times as well. There is a bit of confusion between all these Gazebo different names. So I decided to include here a simple graph. Yeah. So we have Gazebo here, the one at the left, which is Gazebo Classic. Okay. Then at some point, this Gazebo Classic evolved, let's say, into what was known as Ignition Gazebo. Yeah. And then now, in the latest years, Ignition Gazebo has been renamed, rebranded to Gazebo Sim, which is this one in the right. Why am I saying this? Well, I am saying this to clarify all the naming issues between the different Gazebo versions, but also because as of ROS to Jazzy, Gazebo Classic is no longer supported. Sorry. So what does this mean? If you still have simulations working in ROS2, which are based on Gazebo Classic, probably this is a good moment where you should start migrating your Gazebo Classic simulations to Gazebo Sim. Okay, because as I'm going to repeat it, as of ROS to Jazzy, Gazebo Classic is no longer going to be supported. All right. Here I have also left a link to a guide, official guide of the Gazebo Sim documentation on how to migrate Gazebo Classic ROS2 packages. All right. Okay, then let's start running some things. So as of ROS to Jazzy, starting the Gazebo Sim simulator is as simple as sourcing the ROS version and running GZ Sim. We can do it here real quick. Then this might take some seconds, just be patient. And eventually we are going to see here, we should see here automatically appear the Gazebo simulator, Gazebo Sim simulator homepage. There we go. Okay. And this is, yeah, so this is basically the Gazebo Sim homepage. You can see several different simulations here that can be selected to start. For instance, let's select any. I'm going to select this one and click on the Run button. And then this is going to open the selected simulation here. All right. One interesting point about this is that let me wait some seconds until this finishes loading. Okay, there we go. So we have to click on the play button here to start the world and the physics and everything. And then you can scroll down if you want, and for instance, control the robot here with the keys. Let me maximize this. There we go. So I can, yeah, for instance, click on these buttons and start moving the robot. Okay. Now, if we open a second terminal and we execute, let's say, a ROS to topic list command, we are going to see that no topics related to the simulation are there. Yeah, just the default parameter events and ROS out topics. Okay. Why? Well, because this simulation that we have started is a Gazebo Sim simulation. Yeah, it has nothing to do with ROS2 at this point. Okay. Then, in order to start Gazebo Sim integrated with ROS2, we need to start some specific packages, like for instance, the ROS Gazebo Sim, and so on. Okay. Now I'm going to show you an example here. Right below, we have an example. Okay, of a launch file where we are starting Gazebo Sim integrated, connected with ROS2, right? So it's this command here, the gz ROS2 control demos diff drive example, okay? We can copy this command here directly from the notebook as well, and then execute it here. Let's wait some seconds. And here we already can see in the messages that some controllers are being loaded. All this is already ROS-related stuff. Yeah. And here, not here, sorry, now in the simulation window, we have the Gazebo Sim simulation. But now, if we go again to the shell, to the terminal, and we type again ROS2 topic list, we are going to be able to see all the topics related to the simulation, like the command belt topic to move the robot. Yeah, I think I even added a, no, not here, it's later. Yeah, so we have all the ROS2 topics which are associated to the Gazebo Sim simulation that we have just launched. Yeah, if you want, we can have a quick look here at the launch file. Okay, I'm not going to go into details because that would be too much, but we can have a look at this launch file. So let's open the code editor here. Also, you should already be an expert and know where everything is in this project. So I'm not going to stop to explain it. And here, if we go inside the ROS2 workspace, you are going to find several packages, between them these GC ROS2 control demos. Yeah. So inside this package, if you go inside the launch file, you are going to be able to locate this diff drive example.launch.xml. Yeah, here we have it. Yeah. Then here you are going to see exactly what it's being launched for this simulation. Yeah. So you can see the ROS GC Sim package, the ROS GC bridge, the controller manager, etc. Yeah. Then I am showing this because one thing that is currently in development, and it is expected to be released for ROS to Jazzy, but it's not yet finished. It's an integration between Gazebo Sim and XML formatted ROS2 launch files. Yeah. So far you can create ROS2 launch files in XML format, which are pretty simple, as you can see. Yeah, you have to specify some nodes, like ROS Gazebo Sim, create, and you can specify directly the topic where to get the URDF information from. So all this is quite simple, but this is going to be even simplified even more. Yeah, so they are working on some special tags like the GC server world, GC server, the ROS GC bridge, where you are going to be able to load the configuration file directly to the using just a simple XML tag. Yeah. So this is some work in progress. Okay, and for what I have been reading, it should be released soon. It is expected to be released with ROS Jazzy, but it's not yet ready. Yeah. Okay, so yeah, this is so far what we are going to cover about this Gazebo Sim integration, which is very, very interesting. Now I want to move to some more simple examples, let's say, based on command line tools. These are things that you can start using from today. Okay, so if you are developing in ROS to Jazzy, this is going to come in handy for sure. So we are going to see a couple of examples. First of all is the possibility to generate custom log file names. Okay, so probably you don't understand what I mean with this, but let's see a very simple example to demonstrate this. Okay, so we are all going to go to the cd.ros/log. This is the default directory where ROS puts all the log files. Okay, so if we come here, let's come here. I have the simulation here. Okay, so let's leave the simulation running in the first terminal. Let's not close it. I'm going to actually write here something, I don't know, sim, so that I know that here I have the simulation running. And then here, if you go to the home user.ros log path and run an ls command, here you're going to find maybe some folders, some log files. Okay, so let's just remove everything. Yeah. Yeah, let's remove everything from here until we have this directory empty. Yeah, so we have just cleaned all the logs. Okay, so now what we are going to do is to run the following node. Okay, this is a very simple node. You can find it here also in the workspace if you want to see the contents, but just as a very stupid example, where basically we are subscribing to the Atom topic and printing the information of the XY coordinates of the robot. Some very simple program. Then if we run this program by the regular ROS2 commands, all of you know these commands. Yeah, ROS2 run. This is the typical way, well, ROS2 run or ROS2 launch, it depends. But if you want to execute a node quickly, probably you are going to use the ROS2 run. Then if you execute this command, there you go. And then let's open a third terminal here. And we are going to go again to the .ros log. And you type ls again, you are going to see a log file has appeared. All right. You can check it if you want, the contents, and you are going to see that the contents of this file is basically the output of the program I have just executed. Okay, so far so good. This example seems pretty simple, right? But this can become a mess when you are executing many nodes, many programs, etc., and you start getting this folder, plenty of log files where the names are all basically almost the same, right? So all the log files are going to be named Python 3 whatever. Yeah. So okay, how can I differentiate this one from this one? No idea. Yeah. So one cool tool that ROS2 Jazzy brings in is the possibility to actually provide a custom name to these log files. Yeah. And it is very simple. It is as simple as specifying the argument log file name. Yeah. So now, if I execute this command instead of the regular ROS to run without any other argument, let me run it here. ROS to run, so same command, but we add the ROS argument log file name, and here we specify the name. For instance, my logs, but you can put here whatever. If now I execute my program again like this, the log file generated is going to be named like this, my logs. So I can clearly identify this log file corresponds to this program that is being executed right now. Okay, so a simple thing, but I think it can be very interesting, especially for debugging programs and so on, right? Then let's move quickly to the second one. Also a very simple thing, but very important at the same time. Yeah. So all of you, if you have worked with ROS2, you know about the ROS2 topic list command for sure. This is known by everybody, but also the ROS2 topic info, right? So if you want to get information, you use the ROS2 topic info command, right? And then you get information related to this topic. So what is the type? How many publishers are publishing into this topic, and how many nodes are subscribed to this topic? Yeah, very typical day-to-day ROS2 tool. Now, maybe you didn't know this, but for services, there is no ROS2 service command, right? So there is a ROS2 service list command, as you can see, where I get a list of all the services that are currently available. But until ROS2 Jazzy, the ROS2 service info command didn't exist. Yeah, I have added here a small note with the output that you would get, for instance, in Humble or in Iron. If you try to run a ROS2 service info command, it didn't work. Yeah, it was not working. So in ROS2 Jazzy, this command has been introduced. Yes, so let's try it out. Then for this, first of all, we need to, I'm going to start a service, yeah, that I have created here, a very simple service. So we are going to run it here in our second terminal, right? Let's copy paste it here. And then this, yeah, this is the service. Okay. So now, sorry, if we do a ROS2 service list, we should find here this start track post service and stop track post service. Yeah, these two services are provided by this Python script that I have created here. Yeah. Then now we can very conveniently just run the ROS2 service info command in order to get information about a specific service. Super useful. And the information I get is the type that this service uses, which in this case it's the trigger type. And also I get information about how many clients this service has and how many servers. Yeah. So servers are going to be one, but clients, we can see if some client, some node is right now requesting something to this service. Yeah. This can be also very useful for debugging. So for instance, if we try this, I'm going to call this service here from another terminal. Actually, we are going to have to open yet another terminal, but it's the last one, I promise. Yeah. And this is the last terminal that we are going to be opening. Okay. So yeah. Okay, there we go. Here we have the service still running. And then here we have the ROS2 service info, okay, which is showing one service and 0 clients, right? So now what I'm going to do is to call this service from another terminal, yeah? Calling a service basically means creating a client, yeah? Because a node that calls a service is a service client by definition, okay? Then if I call this service and I run again the ROS2 service info, I get 0 clients. Why? Well, very simple. Because the service call was too fast, so I have not been able to detect it. Okay. Then what I'm going to do here is to change to another to call another service, which is the stop track post service. Okay. By the way, all this is making the robot move and stop. Okay, I'm not showing it, but yeah. Whenever I call this stop service, the robot is going to stop moving. Okay. Then here, what I'm going to do is to call this stop service, because here inside the process of the call, I have placed an sleep so that we are going to be able to detect the client. Yeah. So let's call the service. And now, if we run the info command, we are going to be able to see that this service has one client. Yeah. And when the call finishes, which is right now, if we come back, we are going to see that the client is now disconnected. Okay, this is a very simple thing, but very, very useful, especially for debugging, and especially because services are an essential tool. Yeah.
10 minutes.
10 minutes only? Okay. Let me keep going. Okay, then we are done for these command line tools, and we are going to jump into another very, very important topic, and one of the biggest things for me that come with ROS to Jazzy, which is RMW Zeno. Okay, let me stop at this moment. Before starting with this demo, I want you to close all the terminal. Okay, so at this moment, just stop all the programs. And in fact, what we are going to do is to stop the simulation as well, everything. And we are going to close the terminals, okay? I want all of you to start with brand new terminals, okay? So, sorry, there we go. All right, so what is RMW Zeno? So if you've had some experience with ROS2, probably you are aware of the DDS concept, yeah? And you know that under ROS, there is a DDS implementation, yeah? So here I have added a basic graph which shows a little bit this, yeah? So at the top level, we have the user application, which are the ROS2 programs that we create, right? In Python, all these. This would be the higher level, which is the user application. Then behind this, we have the client libraries, yeah? The specific ones, which are, for instance, RCL CPP, RCL Pi, yeah? If you are creating nodes in Python, then you use the RCL Pi client library. If you are writing nodes in C++, then you use the RCL CPP. Today also we have seen the RCL RS for Rust. There is also another one for Java, etc. Yeah. And then behind these client libraries, we have the DDS implementations. Yeah. Usually in ROS2 by default, you are going to be using either Cyclone DDS or Fast DDS until now. Okay. So now there is a new middleware implementation that has been applied, that has been added, which is RMW Zeno. Yeah. And what is the purpose of this new DDS implementation? Well, basically the purpose is to make things easier for developers. Yeah. So when you are working with ROS2 at a beginner level, you might not notice all this, but whenever you start getting into more complex stuff, if some of you have done this, you probably have had some kind of problems with the DDS implementations. What kind of problems? Well, the typical ones are discovery failures, especially, for instance, if you are trying to connect two different robots. Yeah, if you are working within a single robot, then probably everything is going to be easier. But the moment you start trying to connect different hosts, then problems probably are going to arise. For instance, discovery failures. What does this mean? You are not able to see the topics of a robot from an external computer. Another typical issue is difficulty transferring large payloads. For instance, image topics, which are huge messages, point cloud messages also, which are huge. In regular DDS implementations, there are difficulties transporting these type of messages. Yeah. Also, issues transferring data over Wi-Fi. Yeah. Or even deployment complexity. Yeah. Because in order to have this working, you have to start creating complex XML files, and you need to know how to specifically configure them, etc. And many of the problems come because by default, ROS2 works in multicast mode. Okay. Then, in order to try to solve all these problems and make things easier for the users, for the developers, for us at the end, this RMW Zeno DDS or middleware implementation has been added, has been created, and has been added to the ROS2 ecosystem. All right. Then I'm going to start by saying that RMW Zeno can be configured in many ways. Even it can be configured to work with the multicast mode as the regular DDS implementations. But the default mode in which RMW Zeno works is what is known as the Zeno router. Okay. And this is a concept that if you are familiar with ROS1, you can probably relate with the ROS Master URI and the ROS Core. Okay, it's not the same, but in order to get a quick idea, you can think of that. Why? Because you are going to have a Zeno router, which is going to be like the central point for discovery. Yeah, this Zeno router is going to be in charge of all the discovery in the ecosystem. Yeah, so it's going to be in charge to make sure that one node is able to see the other node, and so on. Yeah, but the communication between the nodes is going to be still peer-to-peer. Yeah, so the router, as I say here, acts as a broker for discovery data, and the ROS2 nodes communicate in a peer-to-peer mode. Okay. This might sound a bit abstract, but we are going to do a demo right now, which is going to clarify this. So let's open a new terminal sessions, and we are going to start right now a new simulation. Yeah. Then for this, we are going to source this workspace. Okay. This workspace RMW Zeno. Okay, one thing that I have not mentioned, you have it here in the notebook, but I have just gone over that, is that currently, in order to work with RMW Zeno, you have to build it from source, okay? But I have talked with the developers of RMW Zeno, and they told me that they are planning to release the binary packages soon also, yeah? But because of this, what we have done here is to basically build from source RMW Zeno in this workspace, yeah? So this is why we are sourcing this workspace here. Then second step is to set the RMW implementation. Yeah. In order to change the RMW implementation that ROS2 works with, we have to use the RMW implementation global variable. Yeah. So let's change the middleware implementation by changing the variable, the environment variable. And now we are going to start the simulation, regular ROS2 command. There we go. Okay, so we are going to start seeing some messages here. We are going to see a Gazebo Sim world appear, right? But if we pay attention to the terminal, you're going to see a bunch of errors here. Let me stop and read one. It says, unable to connect to a Zeno router. Have you started a router with? And the answer is no, right? We have not done this. So let's open a second terminal, yeah? And we are going to follow the suggestion by the error messages.
5 minutes.
Sorry? Okay, thank you. Yeah. Then in this second terminal, what we are going to do is repeat the process. We are going to source the Zeno workspace. Here, let's source the workspace where we have built Zeno, and let's export as well the middleware implementation and set it to RMW Zeno CPP. And here we are going to start the Zeno router with the following command. Okay, let's do that. Now, pay attention that in the simulation, right now, there is no robot, okay? So actually, the only things that have loaded here are the Gazebo related things, yeah? Nothing related to ROS has loaded. The only thing that has loaded is the world, which doesn't depend in ROS, yeah? It only depends on Gazebo, yeah? So as soon as I start here the Zeno router, yeah, if we go back to the first terminal where we started the simulation, we are going to see, let me scroll up here just a bit. We are going to see some messages here. There you go. Successfully connected to a Zeno router, yeah? And then as soon as this connection is made, all the ROS2 stuff starts loading. And if we go back to the simulation, we are going to see that actually our robot has appeared here, yeah? So now we have the ROS2 system working correctly, yeah? So actually we can open a third terminal here and run a ROS2 topic list, and we are going to be able to see all the ROS2 topics related to the simulation. Well, actually not as simple, right? Because if I try to do this, I don't see the topics. Why? Okay, I cannot see the chat, but I'm going to assume that everybody is answering because you didn't change the middleware implementation to Zeno. Okay, yes, and that's the correct answer, yeah? So by default, I am not using Zeno. So if I want to establish the connection, I need to source and set up the middleware implementation to Zeno, right? So let me do this. And then here we are going to be able to see the topics. All right. Now, I can, for instance, run also a poop command in order to start sending messages to the command belt topic here. And we are going to see that the robot is going to start rotating. Yeah, you see? And now there is one interesting thing here. So what happens if I stop the Zeno router? What do you think is going to happen? Well, actually, I have just stopped the Zeno router, and you can see that actually nothing happens. Everything keeps working normally, yeah, and the robot keeps receiving the command belt messages and keeps moving, yeah. So why is that? Well, that is because of the concept that I have just introduced here, yeah. So the Zeno router acts as a discovery broker, yeah. So it basically only is in charge of making sure that all the nodes and topics are discovered. But the node-to-node communication is in peer-to-peer mode, yeah. So if I stop the Zeno router, the communication is going to keep working, yeah. And this is a huge difference, for instance, with respect to the ROS1 ROS core, because in ROS1, if you stop the ROS core, everything dies, yeah. So here it doesn't. Then this is a very simple setup because we are okay. Maybe I'm not going to have how much time we have left.
None. We need to finish, Alberto.
Okay, then let me just explain this in 1 minute very quickly. Okay, the last part in 1 minute, I promise. Okay, so here we have seen.
Start counting now.
Okay,
go.
Yeah. Very quickly, because I think this concept is interesting. Then here we have seen a very simple setup because everything is running in the same hosts, right? But another interesting thing about RMW Zeno is that it makes the host-to-host communication very easy. So I had a demo here prepared, but I'm just going to explain it. Yeah. Then if you want to connect different hosts or different robots, all you have to do is to start one Zeno router in each, right? And then you configure each Zeno router to see each other. For instance, in the case of the Raspberry and the ROSject, I can create a configuration file from here and point it to the IP. In this case, this is an IPv6. This is the IPv6 of the Raspberry, right? And in the other side, in the Raspberry, I would do the same, but pointing to the IP of the ROSject, in this case, that I am working, or the other robot. And just like this, you can start in the ROSject the Zeno router, and in the Raspi, the other Zeno router. Or this can be a computer and a robot or whatever, yeah, different hosts. And then with this simple configuration, you can have both hosts communicate between them, okay? So yeah, I just wanted to explain this. Here you have a very other cool thing, which is TF filtering in RVs, but I will leave this for you to check on your own. So yeah, I'm done.
Okay, excellent. Thank you very much, Alberto, for your excellent overview of the new features of ROS2 Jazzy. And yeah, so there are a lot more and many other things, but yeah, so we need to leave something for the rest, so that to be the people interested. So let's go now for the questions and answers from the audience. Remember that we have a tab on the chat on the site that says Q&A. You can put your questions there or vote for the ones that are already there. And then I will transfer the questions to Alberto. So let's have a look at the questions that we have already. One from Rigwit Rohan, that he says, can we expect a proper Gazebo Sim core by the construct in the future, because there is not a lot of resources tutorials available for the Gazebo Sim?
Yes, so actually we have one course on Gazebo Sim, but what we are lacking, especially in the construct, is to actually use Gazebo Sim in all our courses. Yes, so to actually update all our courses so that they use actually Gazebo Sim, because most of them still are using Classic, Ignition, yeah. But we do have a course on Gazebo Sim there. I think it's named Gazebo Sim with ROS2 or something like that. Maybe somebody can share the link there. But yeah, for sure. So taking into account that Gazebo Classic is not going to be supported anymore from now on, then all the new material that is going to be generated is going to be using Gazebo Sim, basically. So yeah, you should expect much more material coming on Gazebo Sim.
And one question here from Sebastian Castro that says, what was the RMW Zeno CPP package installed from source? Because it's not yet available from binaries in Jazzy or something else. So what did you do?
Yeah, exactly. So the RMW Zeno has been built from source in this project. Okay, you are going to see it in this workspace RMW Zeno, and currently this is the only way in which you can install it. Okay, so if you want to use this middleware implementation, you have to build it from source. Okay. Now, I have talked personally with the developers of this. We have a very good relationship, and they told me that they are already planning on releasing binary packages also quite soon. They couldn't give me an exact date, but it's going to be soon.
Okay, another question from Anderson Nardin. He says, from some time, Linux was the standard operational system for robotics. So do you believe that ROS versions which are compatible with Windows will make it more popular? Do you think that this is the standard for future ROS versions to run into Windows? What do you think?
I I'm not sure. I'm not sure. I would say that no. Why? Because most of the developers are working with Linux. Then the possibility that you can install ROS2 in Windows is cool, but I think that the I mean, in order to make ROS2 available to many more people, let me put it this way. I think that it's going to be more important to use maybe tools like Docker than actually being able to install ROS2 in Windows. I think it's going to help for
Interesting.
sure, but I'm not sure if it's going to really make it's going to be a game changer, let's say, that ROS2 is supported on Windows. I don't know, maybe I am wrong, but from my experience and from what I have seen so far, I have seen almost no people using ROS2 on Windows.
Okay, then I think that we are going to stop here the questions because now we have to go to another section. But thank you very much, Alberto, for this. But don't leave the stage.